Waf.
Hey, K-Flan. What are we doing today?
So today we're going to talk about descriptive statistics.
Awesome. What are we going to learn?
Yeah, so we're going to look at two different types of descriptive statistics. And before we get started, I wanted to talk about this module in general because it is focusing on a lot of something called EDA. And EDA stands for Exploratory Data Analysis. So this is what we do when we first get a data set. And one of the first things that we usually want to do is look at some basic descriptive statistics. So we're going to look at measures of center and measures of spread.
So what do you mean as descriptive statistics? Like they're going to describe a data set?
Yeah, exactly. So we're going to take like a column of data and describe it with a couple statistics. The first thing that we usually do is look at something called measures of center. And there's multiple measures of center, but two of the most common ones are the mean and the median. So Wade, I think we need an example to talk about both of these and how you calculate them.
Yeah, one of the classic examples I've seen a lot in data science is a group of people's salary. And I hear that they often will have a different mean and median.
Ooh, okay. Let's go ahead and say that we have 10 people. So let's say we have a group of 10 people, and we're actually going to start with them having the exact same mean and median. So let's just say the mean and median salary are both $100,000.
Okay, so they're doing pretty well.
Yeah, and sometimes, like Wade said, this isn't the case that the mean and median are exactly the same, but in this case they are. So if we have 10 people, I'm just going to draw 10 people so we can see what this looks like. So we have 1, 2, 3.
I love these people.
4 stick figures. That's about all I can draw. 5, 6, 7, 8, 9, and that was 10, right?
Yup.
Okay, so we have 10 people, and let's just say they all have the same salary, just to make it easier. They all have a salary of $100,000. So if we were to calculate the mean is probably the most common statistic that people know about. I feel like they start teaching it in elementary school, and all it is we would take the sum of the salaries and then divide by how many people there are. So if there's 10 people, we would divide by 10. So that's how we would find the mean. And then for the median, this is another measure of center, but it's a little bit different. Instead of taking the sum of the salaries and dividing by 10, we would actually line up the people in order from smallest salary to biggest salary and pick that middle person. So the median is the 50th percentile, and it's the person right in the middle of the data set.
Awesome.
So you might be wondering, why would we need both of these? Like, why couldn't we just do one?
Yeah, they seem like they have the same value. When everyone's making 100,000, it's the same thing.
Yeah, and so here they are exactly the same. But one property of the mean that can be that is different than the median is that it's very affected by changes in extreme values. So right now we only have 10 people, but what if a really rich person came into the room?
So if we have to organize them from lowest salary to highest salary, they would be way over here.
They'd be way over here, so we would do something like this, and this person would be like a billionaire.
Okay, so they're making way more money than everyone else.
Yeah. So with these measures of center, the mean is going to get very, very big very fast if a billionaire walks into the room, because the sum of the salaries is going to increase so much because we're adding that billionaire salary. So the mean is going to increase. But the median, we said, is calculated by just lining them up and then picking the middle person. And the middle person actually is still going to have a salary of $100,000. So overall, the mean is very sensitive to extreme values. The median is not, which makes sometimes the median a more ideal statistic to use. Sometimes the mean's a more ideal statistic to use. I like to look at both of them just to compare them and see what's going on. But those are two very common measures of center. And so another type of statistic that we can measure is measures of spread. So how spread out is the data? So with this specific data, it's not spread out at all. But two statistics that we often like to look at to measure spread are range and standard deviation, oftentimes abbreviated as SD. So the range is the most basic measure of spread. It's really easy to find. We just take the maximum value and subtract the min. And then the standard deviation is a little more complicated. We basically look at how far every single point in the data set is from the mean and then kind of average out what that value is. And both of these, if we were thinking about this data set in general, both of these would be very, very affected by this billionaire walking in because the maximum value is going to increase, and then that value is going to be very, very far away from the mean.
So, so they both try and do a measure of spread, but you're saying that the standard deviation is really the spread from the center, while the range is sort of the entire scope of the data.
Yeah, exactly. The range is just like what's the biggest number minus the smallest number, whereas the standard deviation kind of takes into account, okay, how far is each individual person from the mean on average?
And I'm guessing there's a formula we can use to calculate each one of these.
Yep, exactly. And then also we have Python, which is great. So we can do functions in Python to calculate. If we have a column of numeric data, we can do dot mean, dot median, dot std to find the mean, median, and standard deviation.
Awesome.